This is Calculus 2. Alright, so we're to solve optimization problems. So basically we're finding a mins and maxes. We're finding that amount. Okay, the whole thing. Take the derivative, set it equals 0, and you're going to get a min or a max. And then we plug that in to get whatever word problem out of this. As of word problems, it's basically almost all of them here. Word problems are we're going to maximize something, minimize something. This is the calculus that is used for finances because you want to maximize profits and minimize expenses. Okay, just fire everyone and raise up your prices. Okay, all right. Steps solving. Read the problem until you understand. You can identify the quantity for which maximum, minimum values will be found. Assign a symbol to represent it. Assign symbols represent other variables in the problem. If possible, draw a picture and label it. Determine relationships among the variables. Express the quantity and to be maximized or minimized as a function of one of the variables. Determine the meaningful domain of the function. Find the absolute maximum value or absolute minimum value of a function. Right? Okay, good. That's what we're trying for. All right, farmer, 400 meter of fencing, wants to enclose a rectangular plot that borders a straight river. If the farmer does not fence one side along the river, what is the largest rectangular area can be enclosed? Now, this one, I swear, has been on the AP exam like every year. So, we're talking about two different things. The fence. Okay, if I'm talking about a fence, what values am I talking about? Perimeter. The perimeter, right? Perimeter. So I know my perimeter formula for this one right here would be what?
2 sides plus 1.
Okay, but yeah, let's do the whole thing.
2x plus 1. 4,000 meters
Equals 2x
plus 1.
Very good. 2x plus y. We're trying to maximize the area, right?
Yeah.
Okay, so now what would the area be? X times y. So we're going to maximize one of those and then find the other, right? So that means since I have two equations here, one's for perimeter, the other one's for volume, I'm going to go through and substitute so I don't have two different variables. I want one variable. Variable helps me out. Variables are very nice. Just one. Only one. I don't like that. All right. So let's say, what would y be equal to? Just look at the top. What is y equal to? Okay, so I could say that y is equal to 4,000 minus 2x. That one's pretty easy, right? So yes.
Yes.
Oh, good. All right, I'm glad. All right, so now the next one. So I know that a will be equal to x times the quantity of 4,000 minus 2x. Yes?
Yes.
And since we're maximizing this, I need some more room, so I'm going to insert page, blank page, after. Okay. So I know I have my area equals x quantity 4,000 minus 2x. Distribute area is 4,000 x minus 2x squared, right? So if we're maximizing for what variable here? Say x. We're maximizing for x, right? For x. So we're maximizing the area in terms of x. So over here on the left-hand side, what am I going to write? dA dx, right? Maximizing the area for x. So therefore, it's going to be 4,000 minus 4x, right? So Now, since we're trying to maximize the area, we know that the derivative has to be equal to 0. And that's going to give me a min or max, right? Because the derivative is a slope, right? And a maximum or a minimum would have a slope of 0. So it's going to go up to that point and then go back down. So I'm looking for where the slope is going to be equal to 0 here. So all this right here is pertaining to when this is equal to 0. So 0 equals 4,000. Did I lose an x? No, I didn't. Okay, 4,000 minus 4x. So I get negative 4,000 equals negative 4x. So x is equal to 1,000. Okay, that's helpful. So I'm going to plug it back in to figure out what my maximum area should be, right? Okay, so let's go back. So if x is 1,000, oh, wrong one. If x is 1,000, let's figure out what y would be. Right here, so it's going to be y equals 4,000 minus 2 times 1,000. So y is going to be 2,000. So to maximize my area, the most I would get, my area would be my 1,000 times 2,000. So my area maximized would be 2, 1, 2, 3, 4, 5, 6, and that's going to be, what are my units? Meters squared. There we go.
2 million square meters.
2 million. Oh, sorry.
That's a lot of
Have to do it. See, I don't even know if you guys get the joke anymore. Austin Powers?
Yeah.
Okay, good. All right. So I said a joke the other day, and everyone's like, "What? I don't know that movie." I'm like, "Oh my goodness, what's
It
wrong?"
always
with you
feels
people?
awful.
I know, made me feel like so old. Okay. Anyway, all right. So 2 million maximize. So from each corner of a square piece of sheet metal, 18 centimeters. On a side, remove a small square, turn up the edges to form an open box. What are the dimensions of the box with the largest volume? So, let's do a box. That's my best example of a box. So we're cutting out corners and then folding it up. So the more that I go up on this, the more I'm cutting off, the less surface area I'm using, right? So it's reducing the surface area, but as I'm trying to maximize this. Okay, so let's see. If it's going to be square, right? It's going to be square, so let's give this, I'm going to call this an X, because I like that. X, and it's a square cut out of every X. Alright, so right here, and I know that this, okay, 18 by 18, right? Okay. So 18 by 18 on the side. Okay, so we're going to turn up the edges. So I know I'm maximizing what here? The what?
Volume.
Volume, very good. So if I'm maximizing the volume, I know that I'm going to have right here, from here to here, I'm going to put this piece, let's call this Y, the piece that's not being cut off. So to maximize the volume, I know that I'm going to have V equals, now, the volume is length times width times height, right? So wouldn't that be y times, what would the height be? What would the height?
Still Y.
X.
It would be x, right? Because if I cut out this piece right here, I'm folding that part up.
Yeah.
So I'm cutting out the edges and I'm folding it up. So right here, that's going to be the base of my box. And if I knew how to draw very well, that would be perfect square. And we would be able to see that right there. And that means the sides from there fold up. Those are going to be x is my height. Okay, but what else am I working with now? I'm working for a surface area, aren't I?
Yeah.
So surface area. So the area of this would be equal to, okay, how would I get the area of that?
It's y plus 2 times x squared.
Okay. Y plus 2x. Right? Because I'm doing here to here, right? So it would be y times, no, I'm sorry, plus, right? Y plus 2x, right? Times, like that, right?
What about the cutoff pieces?
Okay, so how would I do that? How would I account for that cutoff pieces?
Minus 4x.
So it's going to be, that would be the whole area, wouldn't it?
Yeah.
Of that whole.
Of the.
Yeah.
That would be the whole area, right? And I know that the whole area is equal to what? 18 squared, right? So couldn't I say that it would be $18, right? So it should be 18 minus 2x, right? Yeah.
If you're trying to find which one, the inside one?
I'm trying to find the whole thing, right? So that would be equal to my what value?
That's the one side.
Yeah.
The y.
The y, yeah.
There we go. So to figure out what the y would be, so we're going through looking at what we have. Okay, I don't need the area out of this because what's going to happen when I start making this into a volume? I'm cutting off of it, right? I'm cutting out. So surface area is going away as I'm increasing the volume. So, but eventually, if I cut off so much, my volume is going to start going down too, right?
Yeah.
I'm not going to have the surface area to go around it. Okay, so that's good. So that helps me out here. So I know that y would be equal to that. Is that going to be helpful for over here, maximize the volume?
Yeah.
That's going to be very helpful, right? Because I know that all this for the area is going to come out to there.
Yeah.
So let's see. So volume is going to be equal to, I'm going to have what? 18 minus 2x squared times x, right? Okay, let's go through and distribute this. I'm going to insert another page. Okay, so volume is equal to 18 times 18. What is it? 224?
300.
324, thank you.
Jimmy did that respectfully.
You did, I know. 3, 2, 4, minus 32 x plus 4x squared. All this is going to be times that x, right? You guys see what I did there?
Yeah.
I just did the little trick to do with when you're expanding a square. It's this squared here, this squared here, and this times this. Oh, times 2. It should be 64.
Yeah.
Thank you. I'm sorry. All right, so that one's 64. I was questioning it at first, but I'm like, oh, maybe. Okay. All right, so we have that. So now it's going to be volume is equal to 324x minus 64x squared.
It's 74.
Should be 30. Yeah,
74? What?
No, it should be 36 if you do 1. 18 times 2 36 times 2 is 72.
72, not 64? Is that what I messed up? What? Yes, it's 30. You right, you right. Man, I am. Thank you.
It's a Friday.
I know, it's someday, my dude. 4x cubed. There we go. All right.
X. Oh wait, never mind.
Okay, neat.
And I'm just kidding. No.
Okay, so now that we can do that, right? Now we have all my x's. So I'm trying to maximize this, right? And so, but think about my domain. Think of my domain. What values can I have? What values can I not have?
Kind of a negative side. Like,
So if I look at my box, right? If I'm looking at the box, what is right here? I have 18 here, right?
you can, but no, you can't.
And then I'm cutting out here, cutting out here. I got x, x. Okay, so that means, what could I have? Logically, think about it.
No side.
It would have to be less than 18 on the side.
Yeah.
Less than 18, okay.
Greater than 0.
But, okay, but the problem is, could x be 18?
No.
No, what's the greatest x could be?
No.
9, but what would happen if it turns into 9?
Y would be 0.
You wouldn't have a box.
We wouldn't have a box, would we? Excellent, right? Okay, that's good. So we know that it's x has to be less than 9,
But greater than 0.
but greater than 0.
So now you can just, on the test, just choose a random number between them.
Okay, yeah, choose random numbers. See, hopefully there's no fractions in there, right?
Yeah.
So it's not like some ridiculous
Well,
answer
I
like
said any
like
number.
324 over 17 or something like
I
that.
said any number. So.
Any number, right? Any number. Okay, so okay, let's go through and do derivative then, right? Okay, so dv dx is 324 minus 144x plus 12x squared. Now, can I factor out a 12? Please say yes.
Yes.
Okay, so
Come to
dv dx, if I'm factoring out a 12, what is this going to be?
No, it's not. Never mind.
give me a thing.
It's definitely not.
27? Yeah.
Huh?
27. Yes.
27, thank you. 27 minus 12x plus x squared. I'm factoring out that 12, right? So what happens to that 12 anyway?
Goes away.
It goes away.
Ooh.
Okay. So now, whenever minimizing, maximizing, we always set it equal to, say it.
0.
Come on, you guys. You set it equal to?
0.
Woo! Yeah, all right. For all those people at home, all right. You guys can play along with the home version of this game. All right, so,
It's interactive.
yes, it is. 0 equals, all right, 27 minus 12x plus x squared. Now, can we factor that? What are the factors of 27? That's going to give me, okay, so 27 is positive, isn't it?
No.
It's positive. And my middle term is negative, isn't it? So that means that both signs are negative.
Yes.
Both signs are negative, right?
Mm-hmm.
And so that has to add up to be what?
12.
12.
It's got to be add up to be negative 12, right?
So yeah.
So I'm going to have a negative,
9.
-3, -9.
-3, -9. So it's going to be 0 is equal to x minus 3, x minus 9. Okay, so now I'm going to have values for this where x is going to be equal to, so x is 3 and x equals 9. But is 9 inside my domain? No.
See ya.
X is not inside my domain, so I do not like that. I do not like it here or there. I do not like it anywhere.
Anywhere.
Oh my god.
Green X.
Green eggs.
I know, would you, could you, in that box?
No.
He just said no, he didn't even try to rhyme it.
I know.
You can do it.
Yes, you can, because you have to put 3 in that box,
No,
right?
you can, or you will be lost.
Uh-huh. Oh.
That's to you, one viewer.
Dr. Seuss is not
One dislike.
bad writing.
Likes in the beginning.
Yeah,
And
he's
also dislike after reading.
Here's my dislike.
I do not like Nick at this moment. I do not like him. Sam, I am. Anyway, all right. Okay, so we know that x is 3. Let's go back to our problem. So if x is equal to 3, okay, let's look. So if x is equal to 3, what is y going to equal? 4? 12?
Yeah.
Thank you. Okay, x equals 3, y equals,
12.
thank you. So the maximum volume, so it's going to be 144 times 3. What is it?
144
I don't know. That guy over there is like mumbling or something.
432
432?
something centimeters squared.
Something squared.
Centimeters squared.
Wrong.
Cute.
I mean cube.
Are we maximizing volume?
Wrong.
Yes, sir.
Okay. It's not bad, right?
It's a whole lot of work.
It's not bad. You have to think about it and think creatively and try to get a mental image of what this is, what it's asking for, and what it's giving you. There's always enough information there to solve for it. Okay? All right. So, like I said, I'm going to leave off right now. So, we're going to finish this tomorrow.
Why is he so long?